This presentation is on determining EKG rate and rhythm. There will be a second presentation in the next module on lethal rhythms, or rhythms that require immediate medical attention. The first thing you need to know before you can determine the rate on an EKG is what the different squares mean on the EKG paper. Each small square represents 0.04 seconds. It's represented by the blue bracket and arrow on this piece of paper. Each large square represents 0.2 seconds, and it's represented by the green bracket and arrow on this paper. Most people just refer to them as small squares and large squares. The common lengths of the different components of the EKG waveform that you need to know for EKG rate and rhythm determination is the PR interval is normally 0.12 seconds to 0.2 seconds, and the QRS complex is 0.06 seconds to 0.12 seconds. So the QRS complex is pretty narrow. Before attempting to identify the rate and rhythm of the EKG strip, you need to determine if it's an accurate representation of what's going on with the patient. If you get an EKG that seems abnormal, always assess the patient. Does the patient look like they're having difficulty breathing? Do they look like their heart rate is fast? Are they flushed? Are they blue? You need to look at the patient to make sure that the picture you get on the EKG matches with what that patient is presenting as. Common causes for artifact include muscle movements, a disconnected electrode, labored breathing. So just go through, do a quick check, make sure all 10 electrodes are connected and in the right area. If the patient has pretty severe COPD, you do have some difficulty. Also, if the patient has large breasts, that can also cause artifact as well. Artifact is normally identified by a wandering baseline or an abnormally large EKG wave size. For example, if the QRS complex goes off of the page. Also, small EKG waves when you can't really identify the QRS complex very well, that's an indication that perhaps the EKG is not a true representation. To determine the heart rate, the first question you need to ask is the rhythm regular? Do your P waves, your QRS complex, and T waves look similar across the strip? Do they occur at regular or equal rate times on the EKG strip? If you answer yes to these questions, then you can assume that it is regular. If it is regular, you can use the grid method to determine the rate. You first find the first R wave that falls on a heavy line, and then count each subsequent heavy line until you arrive at the next R wave. With each heavy line that you count down using the following numbers: 300, 150, 100, 75, 60, and so on. This is only valid with regular rhythm, and it's more of an estimate. It is not a 100% precise method to determine heart rate. If the rhythm is irregular, we recommend that you use the 6-second strip method. You can do that by counting the QRS complexes that fall within 6 seconds, and then you multiply that number by 10. And just so you know, 30 big boxes equals 60 seconds. The final method you can use is the 1500 method. In this one, you count the number of small squares between two QRS complexes and divide by 1500. Now we're going to move into the different rhythms that you would see in an EKG. The one that you always hope to see is normal sinus rhythm. Its rate is between 60 and 100 beats per minute. The rhythm is regular, which means you have RR and PP intervals that are the same. Your P wave is upright in lead 2. All of your P waves look the same, and you have one P wave per QRS complex. Your PR interval is normal, your QRS complex is normal, and you have no odd misfit beats. So basically everything looks like what preceded it. The next thing is sinus tachycardia. Basically it's just going to look like a sped up normal sinus rhythm. Your rate is greater than 100 beats per minute. Your rhythm is regular, so you'll have, P waves looks the same, your P to P interval is the same, your R to R interval is the same. You have one P wave per QRS complex, and your P waves look the same. Your PR interval is normal, and your QRS complex is normal. The opposite of sinus tachycardia is going to be sinus bradycardia, basically a slowed down normal sinus rhythm. Your rate is normally below 60 beats per minute. Well, it has to be below 60 beats per minute to be considered bradycardia. Your rhythm is regular. You have one P wave per QRX. You have a normal PR interval and a normal QRS complex. This is where things get interesting. Sinus arrhythmia. Your atrial and ventricular rates are equal, and it's usually between 60 and 100 beats per minute. Your rhythm is irregular, but in a regular pattern. So it's regularly irregular. Your P wave, you have one P wave per QRS. It's the same shape. You have a normal PR interval, and you have a normal QRS complex. Next is premature atrial contractions, or PACs. PACs may occur with fast, normal, or slow rates. The rhythm is irregular only when the PAC occurs. The pause following the PAC is often longer than the R to R interval of the normal rhythm. The P wave of the PAC is early and typically has a different shape than the sinus P wave. The PR interval may be normal or prolonged, and is usually different from the PR interval for the sinus beat, and the QRS complex is usually normal. In the strip below, the PACs are indicated by arrows. Premature ventricular contractions, or PVCs, the rate is normal, fast, or slow. The rhythm is irregular. The P wave is not usually identifiable in the premature beat. There is no PR interval associated with the premature beat, and the QRS complex is wide with the premature beat. It's very easy to identify these odd-shaped PVCs just because it's a wide QRS complex, and that's easy to identify in comparison to those narrow QRS complexes that you're used to. Next is atrial tachycardia. So the rate is greater than 120 beats per minute. It's normally very fast. It can get up to 250 beats per minute. The rhythm is regular, but if the rate's very rapid, the AV node might not conduct every beat. So you might not necessarily see a QRS for every P, depending on if it's conducting everything. The P wave, there's normally one for each QRS, but it might be hard to identify, again, due to the rate. The PR interval is normal, but might be difficult to see due to the rate. And the QRS complex is usually normal as well. Atrial flutter. The rate for atrial flutter is extraordinarily fast. It's between 250 and 400 beats per minute. The ventricular rate may be fast or slow, again, just depending on how the AV node is conducting. The ventricular response is usually regular, but atrial activity is very regular. Instead of having P waves, you technically have F waves or flutter waves, which have a very characteristic sawtooth pattern, and the QRS complex is usually normal. In the strip below, it is very characteristically sawtooth. You can easily identify atrial flutter when it looks like this. Atrial fibrillation. The rate is difficult to measure, but ventricular rate can be slow, normal, or fast. The rhythm is irregular. There's no identifiable sinus P wave. You normally have an irregular baseline, and you might see tiny F waves. There's no PR interval, and the QRS complex is usually normal, but it might be a little bit wider. For example, the QRS complex on the strip below is a little bit wider than what we're used to seeing.